Hello and welcome. I'm Zadar. I'm the lead programmer at MADFINGER Games, and we would like to talk together with Brandi today about how we use the Unity technology to make multiplayer games. But first, please allow me to introduce our company. MADFINGER Games was founded in 2010 by 4 of my good friends. In these 9 years, we reached 100 employees and released 8 games with 250 plus million downloads. For every single game, we received many rewards and awards, including the most beautiful game on Google Store for Shadowgun Legends this year. How many of you have played Shadowgun Legends here in audience? Oh, a lot. So I don't want to talk about it, okay? I want to talk about this.
Do you remember the last time you woke up and said to yourself, today is gonna be a good day? I do. It was this morning. Why am I so optimistic, you ask? Well, it's kind of hard not to be when you're part of War Games, the biggest spectacle in the universe. And there's you. And all you gotta do is just steal a flag and bring it back. Some people are so negative. Damn, I should have done that differently, or I wish I could turn back time, blah, 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 blah. I never got that. After all, time is what you make it. You give it value. You have all the time in the world. The only question is, how are you gonna use it? You're like, damn. Hey.
Wow. Shadowgun War Games. Thank you very much. Shadowgun War Games is our next upcoming highly competitive multiplayer shooter. It's located in the Shadowgun universe beside the original Shadowgun, Shadowgun Dead Zone, and Shadowgun Legends. We started this project a year ago as a spin-off of Shadowgun Legends, but during the development, we saw the potential of the game and we decided to go bigger and make it better. So we think about it and we said, okay, we are a mobile company. We go mobile first, no discussion. We really would like to make highly competitive game, and we would like to make this game accessible to the masses. For this you need some goals, and we are MADFINGER, so we are really good in making beautiful games. We got awards for it. So we would like take the same quality and stick on it. The same is for gameplay. We are pretty good on making multiplayer games. So we need to take this and make the best gameplay ever. Because we need players to be able to start and learn how to play it to become from the zero to the hero. And of course, to make multiplayer game, you need the gamers, you need the players, and you need to connect them together so they can share the knowledge, they can play together, and they can enjoy the match. But everything has a catch. And in this case, we need matchmaking. Matchmaking is not easy. Matchmaking needs to be fast. Matchmaking needs to be fair. Because if it's not fast, the mobile players will just kill the app, uninstall it, and never return. If it's not fair, they will not play it either, because nobody, even me, don't want to play on rank 1 with someone on rank 27 or so, you don't want to. We really don't want to allow players to experience things like low latency, cheaters, and this kind of stuff. And we need to put all this together as a developers, and we don't spend much time on it, because before, years ago, we were spending, and I was there, we were spending the years making the games. And it's not fun. Really, it's not. It's boring. So we would like to make the very smart, fast development cycles. For this, the core of the multiplier is the networking. Without networking, there is no multiplier. And it really isn't easy piece of cake. It's a complicated thing. There is a lot of services around, and you need to take care about the latency, you need to take care about the synchronization of the players, and a lot of other things. And if you can focus on making games, and we can make games, not backends, and you want to do it fast, you need someone to help you with it. And this is where Unity came on the stage, and we start to collaborate on networking stuff. So for us, it's for both of us, like Unity and MADFINGER, it's a win-win strategy, because they help us to focus on making games. We give them the feedback so they can do the better product for everyone, not just for us. So right now, we should go more technical. So I would like you to welcome my dear friend, Brandi, on the stage.
Thank you so much, Vladimir. I really can't say how much we love getting to work with MADFINGER and developers like them who adopt our stuff really early. They're fantastic guinea pigs and veterans in the space, and it means we all get to learn so much and make our tech and our services as awesome as possible by the time we bring it out to a lot more developers. So we're going to head a little bit more technical and start breaking down some of the technologies that we've been working on together to get war games out the door. Now, there's lots of different ways to ship multiplayer games, but this is kind of a typical topology and a typical flow that you'll see. So as soon as the player launches the game, either implicitly or explicitly, they have to log in, authenticate that you know who that user is, and authorize what services and other elements of the game they have access to. The next step is that they will sometimes want to join their friends. So depending on how social your game is, you may have a friends, party, lobby type service where people can join up before they're ready to go play with other people. The next step is their matchmaking, where either the party leader will directly submit their request to a matchmaker saying, I want to go play Capture the Flag, here's some information about us, or the party service will do it if it needs to go and query data that is server authoritative and submit the request on behalf of the party. Next, you'll get a dedicated game server that matches the kind of game that your players are trying to play and connect you to other people. And in the case where you run out of players or you need to submit a backfill request, that server will go and look for more players. And finally, if you want to connect voice communication channels, this is the point where you typically start to see more and more channels open up, and your players are given permission to access each other. It's a pretty simplistic breakdown, but we're going to go into more detail on each of these. Starting with the player identity system. Unity's been working on a three-part player identity system: authentication, authorization, and admin tools. So the authentication piece is intended to be a white labelable solution where you can create logins with either federated providers or your own login so it looks like your game name. But we help with all the fast, reliable authentication and storage of those users. The authorization component could be used independently, and we'll talk a little bit more about that, but it's there to allow you to authorize your users to access certain services. So for example, if you're using our matchmaker, you could use your own authentication layer or ours, but it would need to go through the authorization step to get a token that would allow it to access that matchmaker later. This helps with hackers and cheating and all kinds of other security issues. And finally, the admin controls are there to allow you to decide how you want to scope your different user data stores. If you're like MADFINGER, you may have players that have been playing your games for a decade, and you want to continue to merge all of those pools so when people show up, they already have their friends list. Or you may want to segregate it per game, depending on how you want to design your different types of services. So the admin controls are there to give you the ability to scope your player identities. In the case of MADFINGER, they actually already have their own player identity system. They have people that already have known them and have signed up for their services and for their games. So in this case, we just need to do a token exchange. So they're using our authorization service for when players log in. They authenticate and authorize with MADFINGER. They token exchange with us. And then they send all of that information back to the game client so that they get both tokens and can access other services downstream. It's pretty simple, so we're going to move on from there to friends, party, lobby, matchmaking type services. How do you get your players into groups together so that they can go play? Unity's new matchmaking system, some of you may have seen the talk earlier today, so I'll be pretty brief about what it does, but there's also a whole nother talk if you want to go watch the video after Unite that goes into a lot more detail about what's here. It starts with the game client and the SDK that you integrate, and right immediately you can start communicating with those identity services and QoS servers. So QoS is your quality of service. It's your latency and packet loss. So pretty much as soon as your players log in, you want to start pinging all of your available data centers with little tiny packets of data called pinging, and you measure your packet loss and your typical latency to a lot of different data centers and hang on to that data on your game client so that then you can pass the information on later to the matchmaker and try to get your players into low latency matches. Represented in orange is kind of the gap that a lot of game developers want to fill for themselves because they have their own social systems, and that eventually in time Unity will also provide services for. But today, if you want to party up your friends, like Zadar would do, you bring your own lobby or party system, and people can connect to that to party up with their friends, or even access server authoritative data like skill or ranking that you don't want the clients to be the authority of. This next bit looks rather complicated, and I won't cover all of it, but the gist of what's in here is a very independently scalable microservice architecture that handles the orchestration of a few match functions running in parallel if you have just a few players trying to come in your front door, or if you have millions, it will independently scale and run massively parallel numbers of match functions to get your people through the queue as quickly as possible. You'll notice these two boxes called Custom Func A and Custom Func B. That just means that you can provide and will provide your own custom match functions. So for example, if you have a really casual game mode and you just want to get people in super fast, that can be completely different logic from your other match function, which could be all about really tight skill matching and hyper competitiveness. It's all up to you to define exactly how you want those different game modes to work. On the back end, we have the director, which is what communicates with Multiplay to tell it, spin up a server, I have a group of people ready to go, or allocate and provide me a server of this type. And then backfill, where the game servers can come back and say, hey, I actually need 10 more players. This is the kind of profiles I'm looking for. And it will run more match functions to bring them back through. And the other great thing that the matchmaking and QoS service enable is that Multiplay has something like 25 data centers that you could potentially bring on board so that hopefully your players get grouped into really tight, fast matches. So if latency is important for your game, you can enable as many data centers as you need to and use matchmaking to bring them to the best possible data center that gives a reasonable experience for all of them. Now, in MADFINGER's case, the first thing it starts to do as soon as you launch the game is start pinging the QoS servers. Then they go to their party and lobby system to party up, and their party leader will submit the request to say, I want to matchmake into this game mode. At this point, this will query their skill data or their ranking data, however we want to do it. to make sure that that remains the authority of what is the ranking of these people, because that's a really common thing to get hacked with highly competitive games. Next, the lobby service communicates to the matchmaker, and inside of here is MADFINGER's custom match function, which is pretty focused on that competitive play today. And then it will spin up a server, and then as the server needs, it will reply back to the matchmaker to get backfill requests filled as it's needed. I'm going to hand over to Zadar, who's going to walk you through a little bit of the reference code for how they've been implementing their quas and match functions.
Okay, thank you. Can you hear me? Okay. The first thing you see on the screen is the snippet of code which we use to find the best region, the best servers for the region we would like to play. And as you can see, it's a quite short piece of code. You need to create an instance of quas discovery client, ask for a list of the servers, because we don't have the list on the server on the beginning. Then you will receive, to the callbacks, you will receive, if it succeeds, the list of the servers, or to the error callback, you will receive the error, what's going on there. Once we're done, we can create the quas job with the filtered list of these quas servers, and we can ask for information about the servers. So we will run this job, and when it's done, you can use the results to filter them as you like to find the best server possible for you. The next, sorry. The next snippet is about making the match request. As you can see, again, it's a very simple code. First, you need to get the authentication token. This functionality is not yet fully implemented, so we use dummy tokens for now. You use this token to create a ticket. You fill the data you want for a ticket because the match function gets this data, and you can filter in the match function these tickets. Then you create a match request. You normally create this request on the lobby because you really don't want to trust the client to do so. And you start the request. Then you wait until the matchmaking service finish the matching, and you're done. You got the match, and you can start the game. As you can see, it's very simple, a few lines of code.
Great. We'll head on to the game server hosting and orchestration and getting all of your players connected. So Multiplay joined us about a little over a year and a half ago or so, and one of the things that they're really great at is scaling your servers on demand. You know, it's the best possible experience for your gamers is to just have infinite numbers of servers up and ready to go, but it would also be infinitely expensive. And so what Multiplay has managed to do over the years is to get really smart about how they scale up and down based on the demand of your players. There have been other talks here, so I'm not going to go into a ton of detail. You can go watch some of the videos. But the gist of it is that you may have some combination of bare metal machines, ones that are sitting around just waiting, and also you want to burst into the cloud whenever you hit those peaks in your days and your weeks. And so they'll figure out in as intelligent a way as they can how to make the most of the machines that are just sitting there, and then also how to make the most of your cloud machines. So when your matchmaker sends an allocate request and says allocate a server in this data center, those little green dots are representing ones that are already allocated, and the gray ones are representing ones that are warm and ready to go. So once your game has been up for a while, you hit the downside of the peak, then you start getting these deallocate requests coming in, and they start spinning down some of the cloud compute instances that you no longer need, manage defragmentation, so you're only putting new server spin-ups into the same cloud machines that already have a bunch in there, and try to start decommissioning them as quickly as you can. So in MADFINGER's implementation, we have the matchmaker that we just talked about a minute ago. It's spun up a Multiplay server environment, which has now sent the IP and port back, which is now being sent back to the game clients. In parallel, we have a monitoring store. So in the Multiplay server environment, that's sending data like memory consumed, CPU consumed, and trying to look for any of the information that might indicate that this server has something that went horribly awry. So when you're sharing compute instances, sometimes 4, 10, 20 of these on a single machine, if one of them ends up being a bad actor and starts consuming all of the resources of the device, you actually prefer to be a little bit proactive and shut it down as needed. So that monitoring store is there to allow the environment to try to make reasonable decisions about when it's the right time to go ahead and shut something down. If it's been stagnant for a while, like on the headless server runtime that MADFINGER creates, they incorporate something called server query protocol, which provides information back to the environment too around how many players are here. Has it been sitting inactive for a while? Is the service, is the runtime even responsive at all? And if it starts to find that maybe it's crashed or something's gone awry, then it can help with the diagnostics. So with this headless runtime and with the players having the IP in port, they connect and they're able to play. And once the match is over, then it deallocates that server, and the players go back to be able to matchmake once again. At this point, we're going to try to swap devices again.
Okay,
so you can show the super cool
6.
demo that you guys have been working on.
Oh, it works.
Yay!
Great. Can you hear me?
Great.
Okay. So the development of multiplayer game is difficult in the way of meaning that to debug it, you need server and several clients. The usual way is to open many editors or build the headless server, build the clients, run the server, then in editor run something, connect debugger. It's, I don't want to say what it is. We made our internal tools to speed up this process, to speed up these cycles. Guys spent just a few weeks to make it. It's awesome. You will love it. I do. And we call it multi-scene play mode. And actually what it does is that you can run entire game, several instances with the server inside one editor. And I will show you how it works. So first, I will use our super great cheat manager to switch to this multi-game. Set I would like 2 clients for now, and I would like to play local on my PC, not connected to Multiplay or whatever. Then I will duplicate this game view, set it as a display too, so because I would like to have 2 clients and server on the bottom, first client, second client. And then when I press play button, it do the magic behind and prepare the game.
Yeah, and something to note here is that Zadar and team have had to go through an awful lot of work to try to get the right kind of iteration and tooling. I mean, what's amazing about this is that you can see exactly what the server, quote unquote, sees, what it's trying to interpolate as it's getting all of this data in from the players in real time as you're looking at multiple players interacting in your scene, which for local super fast debugging is absolutely critical. So in parallel, while they've been working on having to build out a lot of their own tool set, we've been working on some built-in solutions that hopefully will come out with some of the new netcode stacks that we've been talking about in some of our other talks this week.
So what you see right now on the left side, this is the client 1, which I control. I can switch to client 2 very easily. So I control the second one right now. I can shoot, I can do anything, even die. I can do anything I like. And on the bottom, you see this what server sees. Okay. On the left side here, in the hierarchy view, you can see that there was one scene before. When I pressed the play button, there was just one scene. We got very rich post-process system, which then can do a lot of things. We really do a lot of things on the background when you build or press the play button with the scenes and with everything. And this post-process system, actually, if I ask him, can duplicate the scene and start for each scene the game in the sandbox, because we got our own game framework. There is no static things like singletons or this crazy stuff. So we can really simulate everything in one editor. You can connect the debugger, and in one debugger, you can debug the server, 2 clients, or as many clients as you like if you have enough powerful hardware for it. So I hope you like it the same way I like it, because it's awesome. You can kill yourself.
All right, back from the dark humor. Let's talk a little bit more about the netcode. I'm not going to go into a ton of detail about Unity's system here, but I do want to talk a bit about how MADFINGER has been building on top of the Unity transport. Back when we first started working with them, we didn't have the FPS netcode that you'll see in preview coming out of the other talks from this event. So they really had to do a lot of legwork. They were able to use the Unity transport layer for both reliable and unreliable sequence data, and they were able to use the simulator pipeline to emulate network traffic congestion, latency, adding a bunch of noise to the signal, because especially on mobile devices, it's a hell of a time to make, or a heck of a time to make sure that that your players are still getting a reasonable experience, even when the network is always going to have problems. And on their side, they had to do a lot of work to build the higher level netcode. So how you get your RPCs synchronized, how do you build tools that are reasonable for designers to iterate quickly, a lot of that was on them to do the legwork for this game. So I'm going to hand off again to Zadar, who's going to walk through some of the code they built to create RPCs.
Okay, I'm live again. So, the RPCs, you always deal with some kind of communication between clients and client and server and clients, and so on. And the normal solution is use RPCs. Before, we use RPCs based on .NET reflection, which is heavy, CPU, heavy for CPU, for garbage collector, and it's not good. Everybody knows it. So we try to go different way, and we go generation. So we generate the code for RPCs, and actually it's super cool, it's fast, there is no reflection at all, and garbage collector is happy, so everyone is happy. So what we need on the beginning is we need identify somehow the net object which we will send the RPCs between. We need some RPCs handlers, and we use it's very common to use some RPC attribute to mark the method. So this is the very basic, the very backbone for our RPC system. So every method uses the RPC attribute, and every type needs to implement RPC handler and net object. The RPC handler is implemented by the generator, but I will show you later. This is our implementation of the skill. As you can see, we got the activate public method. It's public because it's called by our testing things, so this is why it's public. It doesn't need to be public. And the RPC attribute actually tells that it's a reliable call. In this method, you can see that it's quite short. It does almost nothing. But you can see that there is server and client code marked by MFG, strip, server code, blah, 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 blah. This is super cool because you avoid these copy-paste things that you have two methods and then you have to synchronize the implementation of the methods. It's even better because you can use this in the editor in our multi-scene play mode. So, and we can debug it at once. Once you build the final version, it's stripped, so it's not there. It's optimized. This method is transformed by, again, our post-process in generated code. This, as you can see, the skill itself, the class, needs to be partial, so we can implement the partial implementation, which implements the iRPC handler with process RPC method. And because every RPC is implemented as we call it network message, is our implementation. We do just very simple switch, cast it, and call the method. Super fast, super simple. If there is any field in the message, we just pass the message to the method. There is no boxing, cardboxing, not this kind of stuff. And sorry. And here you can see the the method you use to call the RPCs. Okay, so in this code, you don't call the activate, but RPC underscore activate method. This method asks for an instance of the message, our factory / pool. We send this message through the network and return back to the pool. So we reuse it. Again, garbage collector is super happy. Every sent message on the receiver side will land up in the process message method in the NetScene base. From this message, we will take the network ID. Network ID is the unique identifier of every single object registered in the scene, and it doesn't need to be monobehavior. It can be any type. Once we found it, we call the process RPC method I showed you before. And this is how the message looks like. Again, it's generated code. It's very simple. The activate message does nothing. There is no information at all. The information is the message itself. But I can show you more heavy thing. Here we get the agent action edit message with a field. As you can see, we use synchronization methods which transfer the data into byte stream, send it through the network, and sync it back. The last thing I would like to show you is the base network message. The message as itself, it's again very simple. We got sender ID and target net object ID. That's all. So as you can see, the implementation itself is very simple. The post-process behind the generator is heavy. I don't want to show you, but you can deal with it and write your own very easily. Thank you very much.
Thanks, Zadar. Let's go with that button.
Yes or no? Yes.
Aha, there
You're
we go.
live.
Great. All right, we're almost done. The last bit is about voice chat. So Vivox is another company that joined Unity recently, I think just even a few months ago. And they've been powering voice for some of the biggest games out there for years. And the way that it's typically set up to use Vivox is that either your game server, so if you've spun up a dedicated game server, or a game service like a lobby or party service, will use the server-to-server APIs to set up a voice channel. You know, it has controls where it can say mute everybody or unmute everybody, kick users, update token secrets, so that it can get the channel ready to go. And then once you have a Vivox channel ready, then it sends that information back to the game clients, makes sure those game clients that it knows need to be in that session are given the right permissions to connect, and using either the Vivox wrapper or the SDK, they connect directly to the Vivox servers. And it's pretty much just that simple, so we're not going to go into a whole lot more detail on it today. So MADFINGER's server, the current plan today is that they'll have their dedicated game server, spin up the chat channel, send the information back to the players, and they're able to chat. So to wrap up, there's a whole array of technologies we talked about today, and they're all in varying states of ready or available. So the player authorization that we talked about, just that token exchange piece, is in beta today. The authentication piece, the white-labeled component, will be sometime later this year, coming out in alpha, and the admin controls are sometime later next year. And Multiplay Matchmaking is going to be out in beta next month for our server hosting customers. The Unity transport package is in preview, but Multiplay server hosting and Vivox have been generally available for quite a while now. And I also just want to say thank you so much to Zadar. It's been so much fun.
No, I won't. Thank you.
So thank you all, too, for coming to see us, and come check out the Connected Games booth and chat with us, or come to play Shadowgun War Games on the floor. And I believe there are microphones on each side if you all have questions.
And be kind. So questions or not? No questions.
It is late. I bet you're hungry.
So there is question.
There's one.
I want to know how you deal with cheaters, and since it's a competitive game, in what part of your architecture you manage with it?
I don't get a word.
He was asking, how do you deal with cheaters?
It's tough. This is why we choose dedicated servers, because before we run peer-to-peer, and it's really hard to deal with them. On the dedicated servers, you can actually run the simulation on the server, so you can avoid a lot of cheaters by this. If this is not enough, we have other things I really can't talk about because it's internal technology to this, and I don't want to, the cheaters give a hint how we do it. So, but the dedicated server itself, avoid a lot of these things.
Yep.
Okay, thanks.
Yeah, it's very much around how do you prevent cheating. If they have erroneous data, the server's the authority. It can just stomp it. It will say, no, you didn't actually kill that thing. You were wrong. That thing's still alive and you're dead. Oops.
There's another one.
Question. So what's your take on latency when you were using the library, Multiplay library?
So the typical latency whenever he was working on the local client server demo versus
Or maybe
when
deployed
it's
in
live?
real time and testing with 5-6 devices?
It depends. It depends. It's a mobile, so it really hardly depends on the Wi-Fi you play on. So from 50 to 200 milliseconds.
So you were testing with some fixed bandwidth, and
We try to choose the best connectivity, and even the matchmaking try to put together players with the proper ping. So there is, because even the best ping versus the worst ping can look as a cheating for some people, because you shoot some, but he runs behind the corner and you don't kill him, even if you see you kill him because of the ping. So it's very difficult on mobiles, and you need to do predictions. And even here, the dedicated server can help, because if you run the simulation on the server, everyone should see almost the same.
so the latency problems were solved by you, right, for this game?
Yeah, we use the quas and this kind of stuff to choose the best servers and best connectivity between people and with servers. Yes.
So error correction codes were written by MADFINGER.
Yes. So any sort of forward prediction, lag compensation,
Yes.
to try to make it feel smooth, even when you have high ping, is something that they're working on for their stack.
Yeah.
Unity will have offerings for it. In fact, there's some examples in the FPS sample that we've been talking about in other talks. But for now, they had to do all of that kind of smoothing and interpolation, all that sort of stuff themselves.
Yes.
Right. Okay. Yeah. Thank you.
Yeah, you're
Thanks.
welcome.
All right, I don't see any other questions.
So if there's no questions, oh, one more.
One
So
more.
no, sorry.
I'm very interested in how integration with OpenMatch was. You matchmaking functions, etc. I guess that you are using OpenMatch implementation in Unity.
Let me make sure I understand.
I got the really problem to
So
understand.
OpenMatch is the open source framework that our matchmaker is based on. But the beta matchmaker coming next month is a fully managed service. So it'll be hosted and scaled for you. And you use a command line interface to submit new match functions as you iterate on your system.
Yeah.
So I think your question is, what was it like to work with that system?
Yeah.
Okay.
It's quite simple. It's just the command line. So you create this piece of code and you just publish it. Done. It's like simple.
I didn't pay him to say that. Okay. Thanks, you guys. I'm getting a little too punchy. We should get going.
Okay, so please sign up for beta. We open the portal, so go there now. And we are hiring.
Thank you
Thank
all
you
so
very
much.
much.